Today, we're diving into one of the most frustrating, kind of maddening problems in modern software, those invisible forces that can bring even your most beautifully designed cloud system to a screeching halt. You built it perfectly, so why did it just break?
Okay, just picture this. I bet you've been here. It's peak traffic hour. Your production system, the one that's been running like a dream for months, suddenly just stops working right. Alarms are blaring, the team is scrambling, but you check the logs and no code has changed. So what on earth is going on?
So let's walk through a super common scenario. First, a huge traffic spike hits. No big deal, right? Your autoscaler kicks right in to add more servers just like it's supposed to. But then, the deployment gets blocked. It just hangs. And what happens next? A partial outage, because your system can't scale exactly when it needs to the most. The mystery just gets deeper.
Well, here's the reveal. The culprit? It's not a bug in your code. It's not some random hardware failure. The truth is, you've just slammed full speed into an invisible wall, an intentional feature of the cloud platform itself. And it's called a service quota.
The best way to think about there is like guardrails on a highway. Seriously. They're not there to stop you from getting where you're going. They're there to keep you and everybody else on the road safe. They manage traffic flow and prevent these huge catastrophic pileups. So, and this is the most important thing to get, they are a feature, not a bug. Okay, so now that we've unmasked our silent killer, let's get to know it a bit better. If we're going to navigate this highway, we've got to understand the rules of the road.
And listen, not all limits are created equal. This slide is absolutely key. On one side, you have soft limits, or quotas. These are basically your default safety nets. And the good news is you can almost always ask your cloud provider to raise them. But then you have hard limits. These are, well, they're not adjustable, period. They're tied to real physical things. The hardware, the platform itself. You absolutely must design your architecture around these.
And this brings us to a really critical shift in your mindset. You have to start seeing quotas as part of what we'll call the platform contract. They're a fundamental piece of the deal you make with your cloud provider. They're not some weird edge case you can ignore. Nope. They are core architectural constraints you have to plan for from day one. So you might be wondering, why do these limits even exist? Well, they're there for some really good reasons. First, fairness. In a world where you're sharing resources, it stops one noisy neighbor from hogging everything. Second, safety. It protects both your service and the provider's entire platform from getting overloaded. And finally, it lets providers plan their capacity, which is, the whole reason the cloud can scale like it does. Now this is where things get really interesting, and honestly, a little scary. It's how these limits can set off a chain reaction. If you ignore one single tiny quota, it can trigger a massive cascade failure, a domino effect with a much, much bigger blast radius than you'd expect. Let's see how this plays out. It always starts with something that seems small. Your app, under heavy load, starts making just a few too many calls to a service, and bam, you hit a simple API rate limit. Seems manageable, right? What could go wrong? Well, here's the twist. Your super smart failover logic kicks in. It starts redirecting all that traffic to your secondary region to keep the lights on. But the problem is, you've just taken all that intense, concentrated load and pointed it like a fire hose at a brand new, totally unsuspecting target. And that is the danger right there. That concentrated load now just hammers the quotas in your second region, causing it to fail too. So a single, seemingly minor limit has now caused a complete multi-region outage. The dominoes have all fallen down. Okay, that was the doom and gloom part. Now for the solution. How do we stop being a reactive victim of these limits and start becoming a proactive, quota-aware architect? Well, here's the playbook. This table pretty much says it all. Reactive teams, they only find out they have a problem when their dashboard is already glowing red, after the outage has started. Proactive teams, they set up alerts that scream at them before they even get close to the limit. Reactive teams are scrambling for quota increase in the middle of a crisis. Proactive teams asked for that increase a month ago because they saw the growth coming. But the biggest difference? Proactive teams don't just hope their failover works. They test it. They want to know exactly what happens when they hit that wall. So how do you actually build this stuff into your designs? First, you got to spread the load. Don't put all your eggs in one basket. Use multiple regions or even multiple accounts to avoid having a single point of failure. Second, degrade gracefully. Your system should be designed so that hitting one limit doesn't take the whole thing down. Third, plan for headroom. Never ever architect for 100% utilization.
And finally, and this is so important, make quotas a mandatory part of every single architecture review, no exceptions.
And please, try to avoid these common pitfalls. Don't just assume the default quotas are big enough. Don't forget that these limits are often regional. Definitely don't just monitor your VMs. The API rate limits are what will get you. And if you're not using strategies like exponential backoff, you're just asking for trouble. And for the love of all that is holy, never ever think a quota increase is instant. It can take days.
When you boil it all down, this is really about a new mindset. It's about fundamentally changing how you look at the cloud platform and its boundaries, and then building that awareness into every single decision you make. So I'll leave you with this one thought. The next time you're in a design review, don't just ask, hey, is that quota large enough? The real question, the one you need to be asking your team, is what happens when we inevitably hit it? Because answering that question, that's the key to building systems that don't just run, but that can truly, truly scale.